Hey everyone, in this last video we're going to do a bunch of examples of solving linear inequalities, which works pretty similarly to how you solve linear equations. So the aim of the game here is to, for each of the inequalities given, graph the solution on the number line and also to write the solution in integral notation. So we're combining all the stuff we did in the previous two videos. So for this first example, to solve the linear inequality, we want to get x by itself. So it's the same basic idea as when we solve a linear equation. We're going to add to both sides. We're going to add 3/8 to both sides. And we've got some fractions, so let's just quickly do some side work to figure out 3/4 plus 3/8. Alright, so we get that x is then less than or equal to 9/8. As an interval, this would be the interval from negative infinity to 9/8 with a closed bracket. And to draw it on the number line, 9/8 is a little bit more than 1. There we have it. Next up, we have negative 15 is less than 3/5 z. One key difference between solving equations and inequalities is that it does matter what side of the inequality the variable is on. Because if z were over here, it would be saying something different than it is right now. So in these situations, just so that we keep everything straight, I'm going to turn the inequality around. Just to kind of keep things consistent with how we're doing it over on the left side. And let's see, now I want to get z by itself. I have to divide my coefficient. Since my coefficient's a fraction, I am really multiplying by the reciprocal. So we end up with z greater than negative 15 times 5, which is negative 75 divided by 3, or z is greater than negative 25. Looks like this number line's not going to work. Okay, so I got to draw a new one. Alright, so here's my new number line, and I'm looking at all of the numbers greater than negative 25, so that's everything to the right of 25. And since I have a greater than symbol, I have to use an open circle. All right, next up, we have 6r minus 8 times the quantity r plus 1 is greater than 10r plus 32. So Yeah, this is a lot more intense than the previous two. Remember when you're distributing to be careful about signs. Next, we're going to collect like terms. We want to get all the variables on the same side. And 8 to both sides of the inequality. Let's get some more room here. All right, and what we're left with is negative 12r is greater than 40. So I gotta divide out my coefficient. Remember, and I'm going to be dividing by a negative number. So that means that the inequality sign flips. And we get r less than negative 10 over 3. And 10 over 3 is, what, 3 1/3? So I need an open circle there. And since I'm looking at less than, I'm going to the left. All right, and lastly, we have an example of a bunch of fractions, which is great. Since we have so many fractions, it might be a good idea to clear them out. To do that, we would need a common denominator. So I need something that is a common multiple of 4, 12, 6, and 8. 12 itself doesn't work, but 24, which is the next multiple of 12, is a multiple of 4, 6, and 8. So 24 is going to work. And so this simplifies to 6x minus 2x is greater than 4, should be an x there, 4x plus 21. And if we simplify, we get 4x greater than 4x plus 21. And hey, if we move the variables onto one side by subtracting 4x, we get 0 greater than 21. Which, if you're still awake by now, first of all, congrats. And second of all, this is nonsense, right? That's just simply not true. So what does this mean? We get a statement that's false no matter what x is. So we actually get no solutions. And sometimes that can happen. All right, that wraps it up for section 2.5.